What's up, young mathematicians? Today we're going to talk about function operations. And the good news here is we're just putting together a couple of things that we have learned in the past. So we can take functions that are written in function notation and perform the four basic arithmetic operations with them. Let's jump right to it. Addition and subtraction. We can express that as f plus g of x or f of x plus g of x. Those mean the same thing. Or for subtraction, we have f minus g of x or f of x minus g of x. So let's look at some examples. If we are given three functions, f of x, g of x, and h of x, we'll perform some addition and subtraction with those. So the first example, we have f of x plus g of x. So we would just write that out as an addition problem. F of x is 3x minus 5. And we're going to add to it negative x squared plus 6x minus 1. I'll go ahead and write that second one in parentheses. You really don't have to since it's addition. But let's just get in the habit of doing that when we come across the subtraction problems. So looking down the line here, I only see one x squared term, and I'm going to write that one first. So I have a negative x squared. Now let's combine the linear terms. I have 3x plus another positive 6x, which would be 9x. And then let's combine the constants. Negative 5 plus negative 1. That gives us negative 6. So negative x squared plus 9x minus 6. All right, what about f minus g of x? So we will start with the function f, which is 3x minus 5, and we are going to subtract from that the function g. Definitely need to put the g function in parentheses. I could put the f function in parentheses, but it's really not necessary. So we have a negative x squared here plus a 6x minus 1. Now you can rewrite it if you would like to, but I'm just going to work through it as it is. So I don't have any quadratic or squared terms in the first function here. So we're going to go ahead and write this one first, but we are subtracting a negative x squared, which means positive. So we get a positive x squared there. Now let's combine the linear terms. I have 3x, and I'm going to subtract from it 6 more x's. That would take us to negative 3x. And then I have, for my constant, negative 5, and I'm going to subtract from that a negative 1, which is really going to turn this into addition. So negative 5 plus 1 is negative 4. X squared minus 3x minus 4. All right. And once you pause the video for a second and work out part C. Okay, we're back. Let's see how you did. H of x plus f of x. So we have h of x, which is 5x squared minus 2, and we are going to add to that 3x minus 5. All right, let's combine the like terms. 5x squared, no other x squared terms. So we get 5x squared. And let's combine our linear terms. There's only one of those. So the plus 3x just comes on down. We do have two constants we can add together, a negative 2 and a negative 5. That's negative 7. So 5x squared plus 3x minus 7. All right. So examples D and E, we are just multiplying each function by a certain constant. We'll get to multiplying function by function in the next part. So let's see what we got on D. 2 times f, so I'm going to write a 2 with parentheses and multiply that by the entire f function. 2 times 3x minus 5 plus 3 times our h function, which is 5x squared minus 2. So I'm going to distribute first, and then we'll combine like terms. So 2 times 3x here gives us 6x. 2 times negative 5 gives us negative 10. 3 times 5x squared gives us 15x squared. And 3 times negative 2 gives us negative 6. So let's put all those like terms together. Only one squared or quadratic term. So we'll write that first, 15x squared. Only one x term or linear term, a positive 6x, that comes next. And we do have two constants to combine, negative 10 and negative 6. Together makes negative 16. All right, example E, written in a slightly different way. Why don't you pause the video for a second and work that one out. Okay, we're back. Let's see how you did with that. So we are going to multiply the h function by 2. So that will be 2 times 5x squared minus 2. And we're going to subtract from that 3 times the g function, which is negative x squared plus 6x minus 1. All right, so here we get 10x squared minus 4. And here we get positive 3x squared and negative 18x. Negative 3 times negative 1 plus 3. All right, let's combine those like terms. 10x squared plus 3x squared, 13x squared. Only one linear term, a negative 18x. So that comes next. And then we have two constants, a negative 4 plus 3 takes us to negative 1. So 13x squared minus 18x minus 1. All right, let's look at some multiplication. Can be expressed, fix that, as f times g of x or f of x times g of x. Okay, so let's look at a of x times b of x. That would be x plus 3 times 2x plus 5. So we can multiply those with the FOIL method. You could use the box method, or you can just kind of do the distributive property several times. What is x times 2x? 2x squared, x times 5, 5x. Slide over to that 3 times 2x. That will be 6x, and then 3 times 5, 15. Combine those two like terms in the middle. We get 2x squared plus 11x plus 15. All right. Why don't you pause the video there for 1 second and work example B. Okay, we're back. Let's see what you got. So A, which is x plus 3, and we're going to multiply that by x squared minus 2x plus 4. So a lot of distributing to do here. We have x times x squared, that's x cubed. X times negative 2x, that's negative 2x squared. And x times 4, that's 4x. All right, we'll slide over to the 3. 3 times x squared, 3x squared. 3 times negative 2x, negative 6x. And 3 times 4, positive 12. Let's put those like terms together. No other cube term, so x cubed goes first. We have a negative 2x squared plus a 3x squared gives us 1x squared. And we have a 4x minus a 6x, which is negative 2x. And just one constant, which is positive 12, so bring that down. X cubed plus x squared minus 2x plus 12 is a times c of x. All right, let's look at division. That can be expressed as f divided by g of x or f of x divided by g of x. So this time we use the functions t, u, v, and w. And didn't write the function, so let me stop the video and write that. All right, so for example A, we want to take t and divide it by v. So let me write that out in fraction form. All right, so t is 9x to the 6th minus 3x cubed, and we're going to divide that by v, which is 3x. So we'll divide our coefficients here. 9 divided by 3 is 3. Remember our exponents rules. X to the 6th divided by x to the 1st. That would be x to the 5th. I see a negative divided by a positive is going to be a negative. 3 divided by 3 is 1. X cubed over x to the 1st is x squared. So we get 3x to the 5th minus x squared. All right, B, we're going to take the u function and divide it by w. So u is 12x to the 5th y to the 5th minus 10x cubed y squared. We're going to divide that by 2x squared y. All right, so let's divide 12 by 2. That gives us 6. X to the 5th divided by x squared is x cubed. Remember, 5 minus 2. Y to the 5th divided by y to the 1st is y to the 4th. I have a negative divided by a positive, so that's going to be negative or minus. Let's see, 10 divided by 2 is 5. And x cubed divided by x squared, that would leave us with x. Y squared divided by y, leave us with y. So 6x cubed y to the 4th minus 5xy. All right. Now last, you're not going to be tested on this, but this is something you're going to see in a future course, so I just wanted to introduce you to it. It's called function composition, basically where we take one function and plug it into the other function. It can be expressed like this, f composed with g of x or f of g of x. So what that means is you're going to take whatever is written second, the g function, you'll plug it into f. Either way this is written. All right, so let's look at two examples. F composed with g of x, so just like we wrote it here, we're going to take the g function, we're going to plug it into the x value in f. So we have 2x, I'm going to leave a big space there, plus 5. So in place of this x, as the input is going to be the g function, so x squared plus 3 goes in the f function. So that gives us 2x squared plus 6 plus 5. So we have 2x squared plus 11 for f of g of x. Now, this second example, B, is g of f of x. So we're going to take f and we're going to plug it in to g. So g, x squared plus 3. I'm going to leave a little space there for x. I'm going to square it, and plus 3. So I have to take the f function and put it in there, which would be 2x plus 5. All right, so now we have to work that out, 2x plus 5 squared. I'm going to do a little scratch work up here. So we have 2x plus 5 times 2x plus 5. So 2x times 2x, 4x squared. 2x times 5, 10x. 5 times 2x, 10x. Together, 20x. 5 times 5, 25. So here we get 4x squared plus 20x plus 25, and I still have plus 3 to add on. So our final answer there is 4x squared plus 20x plus 28. So there's a little bit of information about function operations.